Actually, the story of our Reflectarray began a long time before Anywaves were created. It's a technology that have been studied, and this concept have been identified during the 17th, especially for radar application, aerospace radar application, using some waveguides with adaptive lengths to act as a phase shifter and allow a flat surface to behave as a parabola from a wave point of view. So this was very interesting. Then there were a lot of studies, work, developments, especially to see if that kind of technology were capable to replace reflectors, especially for telecommunication application, where extremely big geo satellites are using huge reflectors, because it's very convenient to get flat panels that you can store very efficiently at your satellite level, and so it's easier to put such a big object into a launcher. So very interesting. Unfortunately, for that kind of technology, there are some drawbacks in terms of bandwidth, in terms of, especially when you are working in geo environments, it's a lot of thermal issues due to the sun and the thermal variations of such antennas. So it was very difficult to challenge the competitiveness of our reflector, especially also because they developed huge crazy technologies with carbon fibers, extremely stable reflectors at very high frequencies. So, and it was industrial more than that kind of technology from our history and our technology development. But the first one who decided to use that technology was the NASA and the JPL for exploration mission. First one was Marco, I think, in Higgs band. This type of concept were used on small satellites that was a companion of the primary exploration mission, and this antenna was used to bring the payload data to the Earth with high gain allowed by the surface of the antenna. As you can see, if you take just as an example the fact that it's a 6U form factor, at the end the antenna is larger than the satellite itself. And this is why this technology is interesting. It brings a lot of gain, so a lot of power capabilities in terms of your transmission, especially when you have very long distance or small terminals on ground. It can be also a good application. And thanks to that, this technology has emerged for that kind of application. Definitely, thanks to that mission, NASA has demonstrated the interests to master that kind of technology for exploration, but actually not only. What we did, and that was also the challenge the CNES, the French Space Agency, wanted to address. Having this technology dedicated especially for small satellites, bringing a lot of competitiveness in terms of industrial maturity, the number of units we are capable to develop. Is it interesting both for exploration missions with small satellites, even bigger, maybe tomorrow some rovers or other type of space vehicles that require a big antenna to communicate, and also for different applications like payload telemetry antennas that also require a lot of gain, and telecommunication applications. So on that time, it was in 2020, we won this call for proposal by the CNES, and we started that development. Many technical challenges were addressed because what we wanted to do is to propose a technology that is well suited from Higgs band to Ka band and maybe a little bit higher QV bands. So this requires a significant technology improvements in terms of hinges, because we need to be extremely precise in the way we deploy our panels. We also need to bring a panel technology that is well suited for thermal variation and being as flat as possible independently of the thermal variation that are on the panels. Now, we were the first to deploy a Reflectarray in orbit, the first commercial company that have performed that demonstration. Our goal is definitely to make this technology more accessible to all the players that are going to make some space missions, both telecommunication, payload telemetry, and exploration mission. And what we want to do is to address this market. This is why the French Space Agency decided to support us. This is what we have done a few weeks ago. We are very proud of that, and we are going to continue to promote that technology. Very interesting remark. It's not a pure off-the-shelf product, but what we have done is that we have developed and qualified every components and processes, materials that are going to be used on that technology. As you can see, there is some kind of shape, radio frequency shape we give to the panels depending on the frequency, on the mission, in order to maximize the gain in a given direction. Thanks to that radio frequency engineering, we are capable to do that extremely fast and cost-effective, even for bespoke mission. Everything remains almost the same, which means that the qualification status of this antenna, this is a 30 by 60 centimeter one, will be kept the same and is going to be safe. Another approach we are going to study in the coming years is also our capability to enlarge the surface of this antenna to bring even more gain, to have even more data rate, even more sensitivity to different missions. This can consist in enlarging the panels, but also having more and more panels, for example 6 panels, to get more surface and to earn more gain and more power at our antenna level. It really depends some specificities, obviously, but as a rough order of magnitude, 1 year delivery from the specification, the order to the delivery is a good estimate of the time we need to deliver it. At first, because the more we are going to produce this type of equipments, the more we are going to be capable to make some strategic stock on long lead items on this technology, and it can be reduced over time up to 6 or even 3 months for the manufacturing. They can definitely contact our sales team. We have technical experts that are going to explain further the technology, to understand what is our customer needs, to evaluate more precisely the level or not of tuning we have to perform on that technology, and providing a quotation. This can also be some kind of co-engineering approach, because sometimes you have extremely big constraints at your satellite level. Depends if you want us to deliver the full satellite wall, including all the order and release mechanisms or not. We have many different options. And in all cases, depending on the technicity, the complexity, we will put you, the good experts, in front of you very quickly to address that.